And now it's recording it. So this is what the notes look like. This is exactly the first part you have on your notes, right? Everyone has one of these note packets, correct? Okay, awesome. And everyone has a pen slot in front of you, right? So what I'll do is I'll go over here. Oh, I need to calibrate this. I need to play the calibration game. Oh, this is like the mega calibration game.
This has always been so interesting to me.
Oh yeah. I mean, next time if somebody else wants to do it, you're more than welcome. You just have to center the dots. It's pretty complex, high-level stuff. For being honest, you know.
Is this still recording this?
Oh yeah, it is. Guess all this. And I usually
YouTube.
nice. I end up using like the same recording for multiple classes. Like I'll record Algebra 1 once and then use it for both my Algebra 1s.
So we're like the guinea pig class.
Yeah, usually it'll be the guinea pig class. So if the other class ever gets ahead, they'll be the guinea pig class.
Why other class?
So I'll end up going over to the pen, and let's say I want to start with red. So we'll go through the notes. So Algebra 1 notes, that's the class. Unit 1, pre-algebra, okay? So we're starting off with a little bit of review. You guys had a summer. You guys probably lost some stuff. You guys probably need a refresher of some stuff, okay? So this stuff's hopefully things you've heard. Even if you don't perfectly remember it, it's hopefully a refresher for you more than anything else, and kind of a launch pad, a starting point for us to go into the rest of the year with. Okay, so 1.1, first section of the first chapter, chapter 1, unit 1, section 1, 1.1, algebraic expressions. Okay, so our first part, some important terms, important things for us to remember. Variables. Variables are symbols. That's too fat of a marker. Let's try that again. That's better. Symbols used to represent unspecified numbers or values. Okay? They're symbols used to represent unspecified numbers or values. Who can give me an example of a variable? Victoria.
Like A.
Okay, A. That'd be an example, okay? Dalton. Dylan. Dalton. Dylan. Dalton. Dylan.
Dylan.
Okay, got it right. Dylan. Dalton. Dylan. Dalton. Dylan. Okay, Dylan. What'd you say? X. I would say X is probably our most common one, okay? What about some others? Okay. You can use any letter, right? Okay. You can use absolutely any letter you want, okay? Does it have to just be letters? You can do it in symbols. It says symbols in general. It doesn't say letters. If you really wanted to, you could use a smiley face. You could use a star.
No way.
Okay? If you wanted to, I guess if you're having a bad day, you could use a frowny face. But that one's discouraged. Okay? I like smiley faces more than frowny faces. Okay? But you guys can really use any symbol. Maybe you're just feeling particularly in love that day. You saw someone cute in the hallway and they said hi to you. Okay? And that sets your hearts on fire. Okay? You draw a little heart if you want. Okay? Stuff like that. Okay, so those could be just different examples of variables. Our most common ones are going to be the letters, though. But you guys can use the other ones. It's just not as common. An algebraic expression. It consists of one or more numbers and variables, along with one or more arithmetic operations. Okay, so the numbers and variables. Numbers are the numbers would be like 1, 2, 3, 4. Blah, blah, blah. Variables are these symbols. What's an arithmetic operation? Matthew? Like 2 plus 2. So that plus would be the operation there. Okay? So that plus, minus, subtract, or divide, multiply, powers, those would be examples of operations. Yes, Dylan. Okay, what's an example?
You could do like 2 minus 3.
Okay, 2 minus 3, okay. Jacob said, or excuse me, Matthew said 2 plus 2. I promise I'm not going to get in the habit of that, Matthew. Of saying Jacob. Okay. Another one you could do, you could just do x. That's 1 or more. It's 1. One variable. You could do x minus 3. You could do a squared plus 3b minus 15. You could do 7. Like there's all sorts of different options you can do in there. Okay? So Those are also some different examples of an algebraic expression. Hey, can anybody remind me what the difference between an expression and an equation is, by the way? Okay, Zach?
The equation has an equal sign.
An equation has an equal sign, right? We see the word equation, we see the equa, and it starts with the equal sign. Okay, so it has an equal sign in the equation because the words are the same, equation and equal. Whereas an expression just doesn't have the equal sign. That's the difference. A factor. Factor is the quantity being, what operation does that deal with? Multiplying. So it's a factor being multiplied. A product then, that's what you get when you multiply things together, right? Okay, so you multiply two factors, you get a product. So the product is the value of quantities being multiplied. So the value of the factors 2 and 3 being multiplied would be 2 and 3 being multiplied.
Oh, multiplied.
6. Yes, it would be 6. Okay. Power. An example of a power is to be an expression like x squared. What here is the power? The square, right? That 2, okay? So that's the power there. I'm going to draw a little arrow to that so that way we know, hey, that's our power that we're talking about. It's not the x. It's the exponent. Okay? And what's that mean when something's squared, something to the second power? Yeah, right?
You multiply it by itself.
Yeah.
A number of times.
Yep. It's you multiply by itself that many times. Okay, so in this case we're taking x times x this many times. So there's 2 of these being multiplied together. So it's like x times x is what that means. Change colors just to change it up a bit. So here we see this. What's that mean in words? Who could say what that means in words? 3 to the first. 3 to the first. You can say 3 to the first power, or you can just say 3 to the first. Mathematically, how many 3's are being multiplied then? Matthew? Just 1. Okay, so it's just 3. That's what it means. Levi, how would we say this one? Yeah, 3 to the second. You could also say 3 to the power of 2 if you wanted. 3 to the second. So how many 3's are being multiplied together here? 2. So we end up having 3 times 3. And what is 3 times 3? Right, thank you. Sorry, did someone say what 3 times 3 was? Yes. 9. 9, 9, 9. Okay, 9. What is this? How would you say this bottom one, Serenity? 3 to the third. 3 to the third. Dalton, how many 3's would be multiplying together there? 3 of them, right? So we'd have 3 times 3 times 3. And what is 3 times 3 times 3, or 3 to the third, Zach? 27. Okay. Questions on any of that? So far, so good, right? Okay, we're rolling here. Good work, good work. Okay? Boom. Okay. So we're going to have these algebraic expressions here, okay? Now, we're going to learn how to write them a little bit more. We're going to learn how to write them. So we're going to put the following expressions, these following words, phrases, in the correct operation boxes together below. So for example, product, is that belong with addition, subtraction, multiplication, or division? What would that mean? Danny? Multiplication. So we take product, we'll write it down there, and I'll go up here, word bank, cross product, alpha, used it. Used every one of these. Who can tell me another one that they can fit in there? Okay, Dylan. Okay, decreased, you can put in subtraction. Oops, not addition. Maddox?
Quotient's division.
Yep, quotient would be division. That's the answer for a division problem. Okay, Matthew? Well, for which one? Oh, of, sorry. My bad. Of would end up being multiplication, like 3 groups of 4. Maybe 3 times 4. Cheyenne? Yep, some would be for addition. Very good. Okay. Dylan? Yep, times would be multiplication there. Victoria?
Split up is division.
Split up would be division. Split up into so many groups. Well, let's split up, gang. Shaggy and Scooby, you go down here. Okay. Chase?
Takeaways and subtraction.
Takeaway would be subtraction. Very good. Dylan?
Increased by would be
Yep. Increased by would
addition.
be addition. Presley? Yep, more would be addition. 6 more than 6 plus something. Okay, Dylan?
Less than
Less than would
subtraction.
be subtraction. We used takeaway earlier, didn't we? Okay. So we have one more. Okay. Anybody got that one for us? Difference would be subtraction. Okay, we covered them all, right? Any questions on those? Go. You guys are killing it. So we're gonna practice this a little bit here. So right below this, so write an algebraic expression for each verbal expression. Oh, let me try that again. Write an algebraic expression for each verbal expression. So we're saying for this phrase, this verbal expression, we're saying it's in words, 5 less than a number. How would we write that algebraically, okay? Ray, what are you thinking? X minus 5, very good. Now, hey, here's the thing. It says 5 comes first in the sentence. So why are we putting X first here? What? Yeah, it says less than a number. So we're taking the number and we're doing 5 less than that. So just like if it was 5 less than 7, you would do 7 minus 5 and get 2. Because 5 less than 7 is 2. Whereas if you did it the other way around, and you did it like that, you would not get 2. You end up getting negative 2. That's not 5 less than 7. So you have to be careful with the order there. Very good job. Okay? Volunteer for the second one. 9 plus the product of 2 and the number D. Okay? Zach?
2 times D equals X plus 9.
Close. I like the 2 times D, the product of 2 and the number D. Okay? And somebody help me out with that first part there. Okay, Dylan? So I agree with Zach when he said there was a product of 2 and the number D would be 2D. Yeah, 9 plus that. So it's 9 plus the product of 2 and the number D. So 9 plus 2 times D. And remember, when you're multiplying a number times a variable, you don't have to put the multiplication sign in there. You can just put them right next to each other. That's what it means, is these are being multiplied. Okay? 2/3 of the 2/3 of the original volume V. Okay? Dylan. Yeah, 2/3 times V. Yeah, on number 4, the fraction didn't print for you guys, didn't print for mine either. But it's 3/4. The product of 3/4 and A raised to the 7th power. And it says it has a little note here. What's that little note say at the end? The comma is important here, right? Bless you, bless the rains down after, bless you forget, okay? And not only does it say the comma is important here, there's some explanations. The comma is important here! Okay, exclamation, right? Okay. So the product of 3/4 and A raised to the 7th power. Anybody have an idea of what that, how we would interpret that with that comma being there? Okay, Ray, what are you thinking?
Like the answer.
Yeah.
3/4 A in parentheses and 7 on the outside.
Very good. 3/4 A in parentheses and the 7 as an exponent on the outside, okay? So when we read this, the product of 3/4 and A, comma, that means we pause. So that means we're going to go ahead and do this. And then it says raise to the 7th power. So that means everything that was before the comma is being raised to the 7th power. So we first have this product, and then we raise it to the 7th power. Now why can't we just have this, but write it like the product of 3/4 and A to the 7th power? Is that the same thing? No, because is the 3/4 being raised to the 7th power here? No, but it is here. The whole thing being raised to the 7th power here, okay? So they're very different things there because of that comma. We're going to put those notes away for now. We're going to finish those notes up on next third Wednesday, my dudes. Okay, that's taking that syllabus is due. Because what are we doing Monday? Does anyone know? We're doing math testing, okay? So Monday we're math testing. So make sure you have your computers and you have them charged. Okay, it is new. Okay? So Monday we're doing math testing. Make sure you have your computers and you have them charged, okay? On Monday. So don't forget, Monday, next time we meet, we do not have class tomorrow. Bring your computer and bring it charged.